What if I told you there's a place on Earth where ships vanish without a trace, pilots' radio distress calls that never finish, and the ocean floor literally breathes fire beneath your feet, and most people have never even heard of it? Forget everything you think you know about mysterious ocean zones. Because while the world obsessed over the Bermuda Triangle, a far more dangerous and scientifically documented stretch of water has been swallowing vessels and baffling researchers for centuries. It's called the Devil's Sea. And what's happening there is not legend. It's geology, physics, and documented maritime disaster, all colliding in one terrifying patch of the Pacific Ocean. Located southeast of Japan, between the Ryukyu Islands and the Mariana Islands, roughly between latitudes 17 and 27 degrees north, the Devil's Sea, known in Japan as Mono Umi, sits over one of the most geologically violent regions on the planet. This isn't folklore. The Japanese government officially designated this area as a danger zone after losing 5 military vessels between 1952 and 1954, with no wreckage and no survivors ever recovered from those disappearances. 5 ships, gone. In 2 years, Japan actually sent a research vessel, the Ko Maru No. 5, to investigate in 1952. That ship also disappeared, taking all 31 crew members with it, including scientists. That is not a myth. That is a documented government loss. Now here's where it gets scientifically terrifying. The Devil's Sea sits directly above what geologists call a subduction zone, where the Pacific Plate grinds violently beneath the Philippine Plate. This creates a chain of underwater volcanoes so dense and so active that researchers from the Japan Meteorological Agency actively monitor the region around the clock. There are over 20 underwater volcanic sites within this zone. One of them, Fukudo Kokinoba, erupted as recently as August 2021, creating a temporary island that appeared and then collapsed back into the ocean within weeks. The ocean here doesn't just move. It transforms. It breathes. It builds and destroys land in real time. But here's what most documentaries won't tell you. The real threat isn't the volcanoes themselves. It's what the volcanoes do to the water column above them. When underwater volcanoes release massive amounts of methane gas and carbon dioxide, they can dramatically reduce the water's density in localized areas. Ships sitting on water that has suddenly lost density due to gas saturation can lose buoyancy almost instantly. This is called a methane blowout or gas hydrate dissociation event, and it is a peer-reviewed scientific phenomenon studied by researchers, including those published in the American Journal of Physics and various oceanographic journals. A ship doesn't need a storm to sink in these conditions. The water simply stops holding it up. And that's not all. The same volcanic activity that destabilizes the water also creates sudden and extreme weather anomalies. The heating of surface water from geothermal activity below triggers rapid low-pressure systems, essentially localized superstorms that can form faster than meteorological models can predict. Pilots flying over the region have reported sudden instrument malfunctions that researchers have partially attributed to the region's intense magnetic anomalies. The Devil's Sea sits in an area where the Earth's magnetic field shows measurable irregularities, something confirmed by Japan's Geographical Survey Institute data. Now, someone will say, but planes and ships cross this area all the time today without disappearing. And that is absolutely true. Modern GPS, satellite communication, real-time weather modeling, and stronger vessel construction have dramatically reduced incidents. But reduced is not eliminated. And understanding why this region was so deadly in the past and still demands extreme caution is exactly what separates educated navigation from blind confidence. The Mariana Trench, the deepest point on Earth at approximately 36,000 feet deep, borders this region. The sheer depth creates hydrological conditions that are still not fully mapped. As of 2024, scientists have explored less than 25% of the ocean floor globally. The deep water ecosystems, pressure dynamics, and underwater current systems around the Devil's Sea remain areas of active research. JAMSTEC, the Japan Agency for Marine Earth Science and Technology, continues deploying deep-sea research submersibles in this region, which tells you everything about how seriously the scientific community takes this area. Here's the pattern most people miss entirely. The world treats the Devil's Sea like a ghost story when it should be treated like a textbook. The disappearances were real. The geological violence is ongoing. The methane instability is documented. The magnetic irregularities are measured. Every single mysterious element of this region has a scientific framework being actively studied. The mystery isn't whether something dangerous is happening here. The mystery is how we still know so little about it despite it happening right beneath the surface of the modern world. There are currently over 1,500 active or potentially active volcanoes on the ocean floor, most of them unmapped and unmonitored. The Devil's Sea sits at the epicenter of that unknown frontier, and the ocean doesn't care about your deadlines, your navigation system, or your confidence. It operates on geological timescales that make human history look like a single sentence in a 1,000-page book. The next time someone dismisses ocean mysteries as superstition, remind them that Japan lost a government research vessel full of scientists to this exact body of water and never got a single answer about why. If the ocean can swallow scientists sent to explain it, what else is it keeping from us? Follow for more deep dive content that connects science, history, and the unexplained in ways that will genuinely change how you see the world. Now tell me, do you think there are other zones on Earth with this level of geological danger that we're simply not paying attention to? Drop your thoughts below.